Hi everyone. This is a permutation and combination lesson 4. It's on permutations with repetition, which means you can want to arrange objects which some of them which is identical. They repeat. So they are the same object. So when you arrange them, let's say A and B, if they are different, A, B, and BA are two different arrangements. But you have AA, well, if you arrange AA and AA, well, it's the same. So you won't count them twice. So that's what this topic is about. So far, we learned like fundamental counting principle, and then with permutation, we see varieties of question. So the way to learn is you familiar yourself with different variety. You look at how each question is solved using this concept of permutation, and then you apply it. Now we will see new types of question that will have you arranging a list of objects with repetition with some identical objects. And then after this, all permutation will be done. And then we'll move on to another one, which is called combination. So let's look at this one. So let's look at an example. A bookstore is advertising signed copies of books about 3 famous Canadian hockey players. The first one is Wayne Gretzky. Yes, he's very famous, and but I don't know where he's now. Patrick Roy and Steve and uh, Steve. All right. So the books are arranged this way. One possible arrangement is shown. Sketch all possible arrangement of the 3 books. Okay, well, with these 3 books, it's easy. Wing, Patrick, Steve, Wing, Steve, Patrick. So I just keep Wing there and then swap the other 2. Next, I put Patrick there and then I swap the other 2. Right? And then finally, I put Steve there and then I swap the other 2. So there are total 6 ways or 3 factorials way, because you have 3 objects and then you arrange them. So it's nothing new. However, the bookstore sell out of the Wayne Gretzky book. Yes, okay. And then they replace it with another second copy of Patrick Roy. Oh, look at this. Now, all the one that used to set Wayne now also become just Patrick. So this one turned into, right, like this one turned into Patrick. This one turned into Patrick. This is Patrick. This is Patrick. This is Patrick. This is Patrick. Do we still have 6 unique arrangements? We don't, because it used to be WPS and then PWS, but now it's PPS, PPS, and PPS. It's the same. So instead of 6, we need to count less. So the answer would be less. And then the way to do it is, since there are 2 objects that's identical, you have 3 objects in total, all right, divided, because it will be less. But then 2 of them will be the same, so you divide by 2. So that will be the answer. The answer is 3. The number of arrangement is equal to the number of arrangement divisible by 2 factorial. All right, well, which is just as same as 2. Now let's try another example. Here again, they want to illustrate with a bigger number, but like they just want to lay out, like show you everything, and then how come when you have the same word, they will reduce it. We don't need to go through all the details. The idea is if you have identical object, the number of permutation will be less because you used to have ABC and then BAC. But now if you change A to B, then you have BBC, and then BBC, well, it's the same. Then you divide by 2. You don't double count. So we just jump to the conclusion here on page 89. There's a pattern in the list on the previous page. If a letter appears twice in a word, so if an object appears twice, it's an identical object, we divided the total number by 2 factorial. If the letter appears 3 times, if an object appears 3 times, if there's 3 identical objects, we divide the total number by arrangement of 3 factorial. All right, so therefore, we have this conclusion. Dun, dun, dun. If you want to find the number of n permutation, but there are A object which is the same type, B of them are same type, C of them are same type, and so on, dot dot dot, then this will be your answer. All right, you just n factorial divided by A factorial, B factorial, C factorial. Okay, make sure when you put this in a calculator, you put this in a bracket so that you divide everything. You don't divide by A factorial, but then plus B factorial. You divide by everything. Let's look at some example, then you will see. Now, this example is familiar. We're just arranging some letter. We have seen something before, similar before, but the difference is now they have letter that is identical. Look at Vancouver. What is identical? They have two V. All right. All the other letters are different, so they have 9 letters. If all 9 letters are different, the answer is just 9 factorial. We know that. We see that before. But now, since there are 2V, we just divide it by 2V, 2 factorial. That will be the answer. All right. Next one, mathematical. All right, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 letters. So if they're all unique, different, distinct letters, the answer will be 12 factorial. But it is not. It has 2m. What do we do? Divide by 2 factorial. And it has 3a. 1, 2, 3. So let's divide by 3 factorial. And they have 2 t's. Let's divide by 2 factorial. And is that all? Okay, no more repeat. That's it. All right. So if they have 10 things to repeat, you keep writing it in the bottom. Good. Let's try another example. So Brett brought a carton containing 10 mini box of cereal. Have you seen those in like they're not in Hong Kong, right? Like usually the small one, like they have 4 boxes on one side, right? And then 4 boxes on the other side, like 8 boxes cereal, small boxes. But this one has 10, so just add one more. All right, just add one more on the end. And then they mix and match. And then sometimes all 8 will be different. Sometimes some of them are the same, right? So if you happen to have the one that you like, that will be good. So here you have 3 boxes of cornflake, 2 boxes of Rice Krispie, 1 boxes of Cocoa Pops, and 1 boxes of Stratis. The remainder are all Raisin Bran. Oh, that's okay. So there are 10 boxes. So 3, 2, 1, 1 to 7. So there are 3 boxes of Raisin Bran. So they want you to do some problem solving too. Over the 10-day period, he will eat 1 box at a time. How many different orders are possible if on the first morning he has Raisin Bran? Okay, first day is Raisin Bran. So that's fixed. No combination. There's only one way. But then the remaining 9 days, all right? So if they're all different, you have 9 factorial ways to eat them. However, now you have 3 of them are cornflakes. So if you have C, C, C on day, let's say 2, 5, 6, it's same as having on the day of 5, 6, 2. It's the same, so you don't count them. So you divide by 3 factorial because 3 cornflakes are the identical object. 2 Rice Krispie, and then now Raisin Bran, you already ate 1, so you're down to 2. Okay, so that will be the answer for this question. All right. What's this thing in the middle? Okay, good. And let's try one more example. That will be an interesting application of what we just learned, which is called the pathway station. Pathway. How many ways are there from going from A to B? Let me show you. All right. If you go from A to B, you can only go one direction. You can only turn right and down. 1 way, 2 way, 3 way, 4 ways, 5 ways, 6 ways, 7, 8 way, 9 way. Oh, I may have missed something. Okay, 10 ways. I missed one somehow. Sorry for that. Okay, there are 10 ways. So for smaller box, doing 10 ways is already very tedious, very hard to keep track of what's going on. But then what if you have a bigger box? Then you will find it even harder. So there is a way to do it. The way is this. No matter which path you take, you will need to take 5 steps, right? From A to B. Either 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Or you go 1, 2, 3, 4, 5. So you can think of this question become, you need to arrange 5 different movements. 5 factorials. However, 3 of them are identical. You're moving to the right. And then 2 of them are identical because you're moving down. So that will give you the answer. So if you try that, 5 factorial means 5 times 4, 3 factorial. Why do I stop there? Because I have another 3 factorial down there. So they cancel out. 2 factorial is just a 2. 5 times 4 is 20 divided by 2. The answer is 10. Yes, it works for this one. And then it will work for more complicated example too. So let's try another one. So let's say this one. Okay, I want to go from bus station to the concert hall. Well, how many ways are there? You need to pass through this point. So let's call this a A. So how many ways are there from A to B to A? Well, let's count. You need to do 1, 2, 3, 4, 5, 6, 7 steps. All right, so 7 factorial. But then this 7 step, you have 3 of them have to be right, 4 of them have to be down. And then you can just arrange them in any order. So 3 factorial, 4 factorial, because they are identical. And then from A to concert hall, all right, so you need to do 1, 2, 3, 4 steps. 2 of them are identical, 2 of them are identical, so this will be your expression. Now the final answer question is, what do you do with these two numbers? All right, so from bus station to the concert hall, you need to go from, listen how I say it, you need to go from A to B or A to C. Is it the right way to say it? Or you say you go from B to A and from A to C. Now you say and. Remember last chapter, if you say and, what's the relationship? When you say and, you multiply. If you say or, you plus. Okay? Good. So that's one way. There's another way that you can do it, which is called the index way. All right. Which you go from here. You go. I'll show you the method. You just put one on the side, and then from the intersection, basically, how can you get to this intersection? You think about the previous step. There's one way to get to the top, one way to get to the right, and then those are the way to lead you here. So you just add the number. So you put a 2 here. Okay. The next number, 1 and 2, give you a 3. So every point you just add the previous dot. Okay, gives you a 4 here. For this point, there's no previous dot. There's only one way. So you just copy the number. There's nothing to add. So just a 4. Here, 1 plus 2 plus 1 is a 3. 3 plus 3 is a 6. 6 plus 4 is a 10. 10 plus 4 is a 14. 3 plus 1, right? Add it. And then add that one, 34. And then this is a 5. Add here is 15. Here is 35. Here is 69. Okay. Here, what do you do for this point? Well, there's only one way. There's no two ways to go to this point. So you put 15. All right, just copy. You add them. It's 50. So final answer, 119. Okay, so that's the answer for this question. All right, so here we go. That's lesson 4. And then you can try the homework and then practice. See you next time. Bye.